Hello, hi guys, myself Mubarak. So in this lecture we are going to discuss about Bouveault-Blanc reduction reaction. So in Bouveault-Blanc reduction reaction is a chemical reaction in which an ester, so you can see the ester here, ester is reduced to the primary alcohols. So 2 moles of primary alcohols will produce here. So by using an absolute ethanol, so here the solvent is an ethanol and the sodium metal. So you can see the ester is converting into the 2 moles of an alcohol. So 2 different alcohols, particularly you are getting the primary alcohols in presence of the solvent like the pure ethyl alcohol and the metal like the sodium. So instead of using the ethyl alcohol, if you use an aprotic solvent like the benzene or xylene or toluene, so that reaction is not the Bouveault-Blanc reduction reaction, that is an ester-ion condensation reaction where the 2 molecules of the ester will get condensed to form the ester-ion. If you are using the protic solvent like the ethanol, that reaction will lead to the formation of the reduction of the ester, which leads to the formation of the alcohol. Clear? So what is the role of sodium here? So sodium is a 1 electron donor, so it 1 electron reducing agent. So sodium will donate the 1 electron and it will convert into Na plus ion, sodium ion. Okay, so what is the role of ethyl alcohol here? Ethyl alcohol serves as the proton source. So ethyl alcohol, so Et means nothing but C2H5OH. So it works as the proton source wherever there is the deficiency of the proton. So ethyl alcohol will donate its proton in the form of H plus and ethoxide ion will come out. So this ethoxide ion and this sodium, so both will come out in the form of the sodium ethoxide. So how many ethyl alcohols you are using, those many sodium ethoxide molecules will come out. So this Bouveault-Blanc reduction reaction was proposed by Louis Bouveault and Gustave Louis Blanc in 1903. So nowadays we are not using this reaction. So instead of using the sodium in presence of ethyl alcohol, so directly we are using one metal reducing agent called lithium aluminum hydride. So this reagent is good in case of the laboratory, but in case of industrial purpose we are not going to use the lithium aluminum hydride. So we will follow the Bouveault-Blanc reduction reaction because of the commercial purpose. So in lab, to reduce the ester into the alcohols, we will not use the Bouveault-Blanc reduction reaction. What we will use? We will use the metal reducing agent called lithium aluminum hydride, but in industries we will use the sodium in presence of ethyl alcohol. So coming to the mechanism of the reaction, the first step of the reaction is ester reacts with the sodium. You can see. So I have written here I have written the general formula of the ester. So to differentiate the 2 alkyl group, I will write let the first alkyl group is R1, let the second alkyl group is the R2. The first molecule of the ester is reacting with the first mole of the sodium. Okay, the same thing what happens here, sodium will give the single electron, and comes out in the form of Na plus. It's the first molecule of first atom of the sodium you are using. Where it will give the electron. So before that you can see here the pi bond between the carbon and the oxygen will get polarized homolytically. Oxygen will get the single electron and carbon will get the single electron. They got the free radicals. Now the sodium will give its 1 electron to the oxygen atom and it will come out in the form of Na plus. Now you can see R1C is having 1 unpaired electron. Now oxygen is having 1 unpaired electron and the second electron was donated by the sodium. Now it will gain 1 negative charge. You will get the O minus ion and here you can see OR2. So now you got the radical ion. So here you got the radical anion. This is the same step we can see in the ester-ion condensation reaction also. In ester-ion condensation reaction, sodium will give 1 electron to the ester to form the radical ion, but in ester-ion condensation reaction the 2 moles of radical ion will get coupled to give the dianion, but here it will not happen like that. So what happens is this radical ion will react with the ethyl alcohol C2H5OH. So this ethyl alcohol, what it will do, it will donate the proton. it will donate the proton. So and it comes out in the form of C2H5O minus, sodium ethoxide ion will come out. So where this proton will attack? So proton will attack on negatively charged oxygen atom. So negatively charged oxygen atom will take the H plus and convert into OH. So now you can see the structure of the products. On oxygen you are having the negative charge. Now you will get one H on the oxygen, as well as you are having the free radical on the carbon and O and R2. So total now, up to now, we have used 1 molecule of sodium and 1 atom of sodium and 1 atom of sodium ethoxide. The next step is this. This will react with the second atom of the sodium. The sodium will give its 1 electron to the free radical carbon. So 1 electron will get attached to the free radical carbon and it will convert into carbanion now. Okay, so now you will get R, C, O, H, here O, R2. Okay, so now what you will get? You will get the negative charge here. So now you got one carbanion. So this carbanion react with the second molecule of ethyl alcohol. So ethyl alcohol plus C2H5OH. So what is the role of ethyl alcohol? So ethyl alcohol will donate the proton. Okay, so along with this, ethyl alcohol will come out in the form of the sodium ethoxide. So now this negatively charged carbon will take the H plus and convert into CH bond. So you can see the structure now here, R1COH, and here you can see you will get the H. This H is coming from the ethyl alcohol, OR2. So total up to now in this mechanism we have used 2 moles of sodium and 2 moles of ethyl alcohol. So what is the next step? Next step is the elimination of the alcohol. So you can see between carbon and the oxygen you are having the 2 electron. So this 2 electron will get polarized towards the oxygen, and between the carbon and hydrogen you are having the 2 electron. This 2 electron will polarize towards the oxygen. So now because of this oxygen will get the negative charge and this carbon will get the positive charge. Okay, so this oxygen will get the negative charge and this hydrogen will attain the positive charge. So this RO minus part will grab the hydrogen in the form of the H plus and comes out in the form of the alcohol. So you can see here R2OH. So 1 molecule of the alcohol came out. So here we have not yet used any sodium or any ethyl alcohol. Along with that the byproduct is R2C double bond OH. So you have got an aldehyde. So again the reaction start. This aldehyde further react with the second molecule of third molecule of the sodium. So so first we have used here, second we have used here, so third we are using here. So what is the role of sodium? Very simple. Sodium will donate its 1 unpaired electron to the oxygen. Here there is the homolytic cleavage between the carbon and the oxygen. You can see the what you will get. Again you will get 1 radical anion. So on oxygen you will get the negative charge, and carbon you are having 1 free radical. Okay, so again you got 1 radical anion. So next, once you got the radical anion, so what will happen? The next step is reaction of the radical anion with the ethyl alcohol. So ethyl alcohol is the proton source. So ethyl alcohol will donate 1 proton to the O minus, and it comes out in the form of C2H5O minus. So what you can see here, now you will get a free radical R1COH, and you are having the free radical on the carbon and H. So next step is same. Now we are using the fourth mole of sodium. The sodium again will give the 1 electron to the free radical carbon and convert it into the carbanion. So you will get R1COH, you will get the negative charge on the carbon and H. Again you got the carbanion. The next, so once sodium was reacted, next step is the protonation. This protonation was done by the ethyl alcohols. Ethyl alcohol will give the H plus to the carbon. So finally you can see R-COH H, and so this H from the ethyl alcohol, so minus C2H5. So total how many moles of sodium atom we have used here? So here we have used 4 moles of sodium atom. You can see here 1 here, and second sodium atom is we have used here. This is the third sodium atom, and this is the fourth sodium atom. So wherever we have used sodium for the reduction, the next step we have used ethyl alcohols. Along with the sodium we have used 4 molecules of ethyl alcohol. That means the 4 protons we have inserted. So now you will get the 4 molecules of sodium ethoxide as the byproducts. So now you can see this hydrogen and this hydrogen and this hydrogen. So in this alcohol was donated by the ethyl alcohol, as well as the hydrogen in the second molecule of alcohol was donated here. So complete reaction you can see in this reaction. Okay, so what you have done here, so we have broke the bond here, and as well as pi bond we have broke. So total on this hydrogen, one on this oxygen, 1 hydrogen was added, again on this carbon 2 hydrogen was added, again on this carbon 1 hydrogen is added. So total we have added the 4 atoms of the hydrogen. So you got the 2 types of alcohols. Okay, so one is having the more number of carbon atom, another is having the less number of carbon atom. Suppose instead of ethyl alcohols, if I took the hydrogen here, instead of hydrogen if I took the deuterium here, so how to write the product? Okay, so sodium was there, ethyl alcohol, instead of the hydrogen deuterium alcohol, so I have took here. So very simple. What is the trick is you have to break the bond here. So after breaking the bond, make the pi bond. Okay, so add 1 deuterium on the oxygen and the 2 deuteriums on the carbon. So the 2 deuteriums on the carbonyl carbon and 1 deuterium on another oxygen. So product you can see here, you will get R1C oxygen. Okay, second part is R2O. Now on this oxygen 1 deuterium atom and 2 carbon atom. Okay, so on this oxygen you are having only 1 deuterium. So okay, you got the 2 types of alcohols, both are primary alcohol but different number of carbon atoms. Suppose if I took methyl acetate, CH3 C double bond O, OCH3. So this is the methyl acetate. So methyl acetate, when I am reacting with sodium in presence of ethyl alcohol, so what will be the product? Very simple. So just break the bond here, add the hydrogens. Okay, this CH3CO, so 2 carbon alcohol. So what is the 2 carbon alcohol? It is an ethyl alcohol, CH3 CH2OH, and so right hand side you are having only 1 carbon. So what is the 1 carbon alcohol? So methyl alcohol. So whenever methyl acetate reacting with the sodium in presence of ethyl alcohol, you will get the 1 mole of ethyl alcohol and 1 mole of methyl alcohol. Suppose if I take the ring, if ester lactones I have took here, so what will be the product? Suppose here I have took the caprolactam. So now when I am reacting this with the sodium in presence of the ethyl alcohol, so how to write the product? Okay, so just break the bond here, add the hydrogens. Okay, so one side 1 2 3 4 5. Okay, so total number of carbon atoms you can see, the ring structure as it is I will write on the oxygen, H here and here H. Okay, total you are having 2 hydrogens. Okay, so with this we have learned about the Bouveault-Blanc reduction reaction. So Bouveault-Blanc reduction reaction and SOL ion condensation reaction, so both are using the sodium metal, and that solvent is different. In SOL ion condensation reaction we'll use the aprotic solvent like the xylene or toluene, but in Bouveault-Blanc reduction reaction what you will use? We'll use the protic solvent. So but in laboratory lithium aluminum hydride is the better reagent than sodium in presence of ethyl alcohol, but industrial purpose they will adopt this method. Thank you students.